Okay, welcome to this tutorial on solving linear equations that have fractions. Now, I'm not going to go through how to solve the whole problem here. Rather, I'm going to show you how we can start it off that gets it to something manageable for you to use. So if we look at the first one here, 2x plus 7 on 3 is equal to x plus 4. Before we can equate these, now we're trying to solve for x, we want to get rid of that denominator. Okay, so we're going to multiply both sides by 3. Now that's going to give us 3 times 2x plus 7 on top of 3 is equal to 3 times x plus 4. Okay, so now we have 3 here at the top and the bottom, so that can cancel. So we're going to have 2x plus 7 is equal to 3x plus 12. And now it's just a matter of moving the x's onto one side and the number on the other, and we can see it's going to be easier to move the x over this side, so we're going to take 2x from both sides and take 12 from both sides. We're going to get x is equal to minus 5. If we look at the second one here, okay, now this is where it's a little bit different because both sides have a denominator, and what we want to do is we want to make them have the same denominator, because if they have the same denominator then we can equate the numerators. The numerators are equal. So that's the key with all of these fraction questions. Let me say that again. It's about making them have the same denominator. And the way we do that is a bit of tricky algebra. So what we're doing, the simple trick to do, is we look at this side. This side has a denominator of 5. So what we're going to do then is we're going to multiply this side by 5 on 5. And the reason is 5 on 5 is 1. So we haven't really done anything. All we've done is multiplied the side by 1. 1 times itself is just itself. It stays the same. We have 5 times x plus 5 on top of 5 times 2x. Okay, so we've multiplied this side by 1. We're going to do the same over on this side. We're going to multiply this side by 1 as well. But this time, so we have minus 8 on 5 on this side. We're going to multiply it by 2x on top of 2x, because 2x divided by 2x is still 1. Okay, that's just 1 there. So we haven't changed the equation at all. We've just multiplied both sides by 1. Okay, now if we're going to expand this, we're going to see at the top, now I'm not going to expand the top just yet, we've got 5x plus 5 on top of 10x is equal to minus 8 times 2x on top of, and we can expand the bottom, 5 times 2x is 10x. So because the bottom is equal, we have both denominators are the same, 10x here and 10x here, it means the numerators are equal, and that's the trick. So we no longer need to write the denominator because we're solving for the numerator. So we get 5 times x plus 5, which is going to be 5x plus 5x plus 25 is equal to minus 16x. Alright, so we're going to move this 16x over this side. So we're going to plus 16x to both sides. We're going to have 21x equals minus 25. So x is equal to minus 25 on top of 21. Okay, so we can see a clever little bit of algebra. The trick is, so most of this stuff from here downwards, we should be pretty comfortable doing that by ourselves. The trick is to make them have the same denominator, and you do that by multiplying each side by 1, but what you're multiplying it by is the other side's denominator. Okay, so if we move on to E here, I'm just going to make some space here for us to do question E. You can pause at any time if you want to see these other examples. Okay, with E, we have 3 on x is equal to 5 on x take 6. So again, we want to get rid of the denominator. We want to make the denominators the same so that we can equate the numerators. So we're going to multiply the left side by 1. And indeed by x take 6 divided by x take 6, okay, because x take 6 divided by x take 6 is 1. So we have x take 6 on x take 6 times 3 on x. And this is equal to 5 on x take 6. And we're going to multiply this side by 1 as well, because it's going to stay the same, but we're going to multiply it by x on x. Okay, we're multiplying it by the opposite side's denominator. So we're multiplying by x on x. And now we can see if we expand this, we're going to have 3x take 18 at the top, on top of x times x take 6 is equal to 5x on top of x times x times x takes 6. Now again, the denominators are equal, which means the numerators are equal. This means we have 3x take 18 equals 5x. Okay, we're going to take 3x from both sides. 2x equals minus 18. And we're going to get x equals minus 9. Minus 9, there we go. Okay, again, same trick. We've multiplied both sides by the opposite denominator divided by itself. We're multiplying it by 1. It's not changing the sum. Let's have a look at h. Okay, now this one again is a little bit trickier, and the reason is because of the 3 different denominators. Okay, so firstly we're just going to start working with the left side. Alright, and we're going to make everything on the left side, which is x take 1 on 8 plus 2x on 3 have the same denominator. So we're going to multiply the first part by 3 on 3. Okay, so we're multiplying this part by 3 on 3, because 3 on 3 is just 1. So we're going to have x take 1 on 8, and then we're going to multiply the second part by this denominator, 8 on 8. So we're going to have plus 8 on 8 times 2x on 3. Now we're just dealing with the left side for now, so let's expand the left side. We're going to have 3x take 3 on top of 24 plus 8 times 2x is 16x on top of 24. Okay, this is the left side. Now let's collect the like terms. Because they have the same denominator, we can perform this operation. This is 3x take 3 plus 16x on top of 24. They have the same denominator, and that's going to be equal to 3x plus 2 on top of 4. So what do I need to multiply this side by in order to make sure it has the same denominator? 4 times 6 is 24. So we're going to multiply this side by 6 on 6. Okay, 6 on 6 is 1. 1 times itself, it's staying the same. The magnitude, the value of it, is not changing. So let's expand this. Over here we've got 3x plus 16x is 19x, take 3 on 24 is equal to, now 6 times 3x is 18x plus 12 on top of 24. Now again we can equate the numerators because the denominators are the same. We have 19x take 3 equals 18x plus 12. Should be something we're pretty comfortable doing. Take 18x from both sides. We're going to have x over here, add 3 to both sides. X is equal to 15. Okay, now please pause at any time because these are 5 different questions that we're going through. So maybe just look at the first example and then have a go at the first question. Okay, last example here. We have x on x plus 2 times x on x take 3 is equal to 2. Now, this one looks a bit complex, but it's actually not too bad. Again, we're doing the same thing. We're going to sort out the left-hand side first so that it has the same denominator, and then we're just going to equate the numerator. Okay, so the denominator, we're going to multiply the first factor by x take 3 on top of x take 3. All right, we're multiplying it by this denominator. X take 3 divided by x take 3 is 1, so we're not changing its value, times x on x plus 2. Okay, now we're going to multiply the second factor by this denominator, x plus 2 on top of x plus 2. And now we're multiplying that by x on x take 3, is that factor. Okay, and all that's equal to 2. So let's expand these. Now we're not going to expand the bottom, we're just going to expand the top. Okay, so x times x take 3. So up here we're going to have x squared take 3x on top of x take 3 times x plus 2. And over here we're going to have x squared plus 2x on top of x take 3 times x plus 2. Now before we can equate the numerators, in order to solve this problem, we need to make sure that this side also has the same denominator. So we are going to in fact multiply this side by x take 3 times x plus 2 divided by x take 3 times x plus 2. Okay, so now they all have the same denominator, alright, which means all of the numerators are equal. So we have, now let's collect our like terms here, x squared plus x squared, we've got 2x squared, and minus 3x plus 2x is going to give us minus x, is equal to the top of the right side, 2 times x take 3 times x plus 2. Okay, now here's one where we have to use FOIL, and I understand we haven't gone over that, but it is something that we have learnt previously in year 9. So let's expand this one. 2x squared take x is equal to 2, and we're going like this. First factors, outside factors, inside factors, and the two last factors. Okay, so we're going to do x times x is x squared, x times positive 2 is plus 2x, x times minus 3 is minus 3x, and x times minus 3 times 2 is minus 6. Okay, and all that's multiplied by 2, so here we've got 2x squared take x is equal to 2x squared plus 4x take 6x take 12. Okay, messy, but we're almost done. Now we're going to take 2x squared from both sides, that's going to cancel that factor, and we're going to move the number over to that side, and we're going to collect the x term. So here we have 4x take 6x, that's going to become minus 2x, and then we're going to plus 2x to both sides. Okay, plus 2x to both sides, that's going to make this have 0 x's, and over here minus x plus 2x gives you x. X is equal to minus 12. Okay, so that was a difficult one, and you probably won't be asked one like that in your test, but that's how you go about solving it. Hopefully the other examples were fairly useful for you. So if we look at the examples back up here, pause the video at any time, look down, copy it down, watch it over and over if it helps, and send me an email if you have any more questions.